Hi, this is video number 6. Sorry about that, I pushed the wrong button and I cut that last video off a little bit. But anyway, we'll go right back to it. We'll check that joint. It's absolutely perfect. That weld was run, and you would think that it would draw back a little bit. On this material and this short of a weld, it won't do it. If it's held by this one strong tack, that's all it takes. Now, what I was telling you about, if you start this weld on this tack, this is under stress right now because of that other weld. If the heat hits this for a moment, it'll soften it up and then it'll draw that way. So that's why I'm saying never start your weld on a tack. Start it over, away from it. If you had 4 tacks, don't start the weld right on top of the other tack on this side. Just, go in a little bit and keep the strength there. So we'll just weld this other side, get it finished. Exactly the same as the other one. The numbers seem to be pretty good. It was a pretty good guess. Sometimes you get lucky, but those numbers are perfect for this material. So let's just go ahead and weld this out. It's a good habit to get into that when you finish a weld, any kind of gas shielded weld, when you stop, keep the nozzle there just for a split second. Allow that weld to cool. There'll be a little bit of inert gas just kind of falling out of the gun, and that will protect that weld just for a split second. It'll stop contamination of the crater. So we have a decent weld there as well, and now we're going to turn this sideways. We're going to weld our flat. I'll weld it first and then I'll explain some things about it. Well, the irony of that was I just ran out of wire. I knew from a previous video there when I was looking inside the machine that I was about to run out. So anyway, you really don't need to see it to understand it. But what I was going to explain kind of popped into my head. When you're doing any kind of weld, let's say it's a fillet weld, the gun as a starting point should always be, this should be 45 degrees, right? So if this is a 90-degree joint, this should be 45 degrees. When you're doing this flat joint that I was doing before the wire ran out, if you were to look at it sideways, you would have noticed that the gun, I hold the gun so it's straight down. It's completely perpendicular to this weld. It's not like because I'm way over here on the side of the bench that I'm gonna reach out and have the gun running this weld like that. Big no-no. What you're going to end up causing is lots of spatter. You may weld for years and not even understand why you created all that spatter so many times. And if you run that gun straight in there, you will minimize spatter like you wouldn't believe. Same thing as the 45-degree thing there. It minimizes spatter, but on a fillet, it's kind of important to eliminate undercut. If this was a vertical and you're welding a little too much like this, you'll get undercut because the heat's a little too excessive from the arc and it causes this to melt out. It can be caused by many different reasons, but that's one of the most common reasons, or basically you just got way too much heat. So if you have say you're welding a pipe joint, and there's lots of different angles when you're welding a pipe joint, but it may be like that, and all sorts of weird shapes or what have you. Just need to remember that it's always, you just take this angle right here and just split it in half, and that's where that gun should be. That gun should be, the halfway point. So if it was 60 degrees, then this would be 30. You know, if this was 100 degrees, then this should be 50. You know, and once you get used to doing that all the time, you'll definitely create much nicer welds. One of the most important things to create really beautiful welds, and I've worked with some folks that have 20 years experience, and it's taken them a long time to understand that it's really actually quite a simple trick to create a robotic looking weld. Is so smooth and perfect. The number one reason for perfect weld is travel speed. That's what separates robots from humans. Other than that, everything's exactly the same between, you know, the welding machines are the same. They're geared up to a CNC machine or a robot arm or what have you. The guns are the same, the tips are the same, the wires are the same, everything's the same. Biggest difference is that the robot's not shaking around, and the speed, the travel speed across the face of the weld is consistent. And if you start to think of it that way, and you start doing your welds not in a, you know, I'll exaggerate it, but not in a herky-jerky kind of fashion, like welding a little and then moving forward, welding a little, moving forward. You need to be consistent with your pace across. It should be, you know, you should treat it like, you know, pretend you're a robot for a change, you know, and maintain that travel speed. You know, it can't be up and down. It's got to be very steady, and that will create a beautiful weld. More so than anything, but it's not the only one rule to create a beautiful weld. It's one of the most important reasons for a beautiful weld, especially a smooth weld. So anyway, I'm going to have to change the wire. That's something anyone can do, so I'm not going to really do a demo on that. But so that's the end of number 6, and I'll come up with something else, and we'll go from there. And maybe we'll make something small or something like that.